And as we go, feel free to share anything you'd like to in the chat or the Q&A feature down here at the bottom of your screen. I'm also going to be starting a poll for people to take as they enter, just a few questions to find out a little bit more about why you're joining and who you are. And I'll start off by sharing my screen. We do have some slides for this, and then we'll also be going into some live demos in a little bit. But overall, we're talking about ChatGPT and similar chatbot type models, as well as artificial intelligence as a field in general, something that's been in the news a lot recently. And we're focusing on risks and opportunities with this kind of machine learning or artificial intelligence. And we'll talk more about the difference and similarities between those two terms in a while. I know they often get used interchangeably. But for a brief round of introductions, my name is Mark. I know I've interacted with a lot of you in the past. My role here is as operations manager, but I also do instruct some of our courses, including the machine learning courses. So I was excited to have this opportunity to share a little bit about what we do in those classes and how our students can also start to chip away at this exciting new field. And Malcolm, I was wondering if you'd like to introduce yourself.
Yeah, my name is Malcolm. I'm a software developer at KTBYTE for going on 3 years now. I don't teach any classes, but I do use AI tools in my my day-to-day work, programming the classroom environment that our students use.
Awesome, thanks. And even though it's not a sentient being, I did want to introduce ChatGPT as the main model that we'll be dealing with today. I think it's the one that's been in the news the most, though it has a few variations now. And it still works a lot like a regular chatbot, like you might find on our site, or many websites that you interact with these days have a very basic version of a chatbot on them. But this one can do a lot more, as you may have heard, and as we'll be demonstrating during the seminar. It's trained on lots and lots and lots of text from all over the internet, which kind of comes into play in how it responds to things. And based on that training, it's trying to output a sequence of words in response to a prompt. So as we get into what machine learning is and how we got to a really advanced model like this, a lot of artificial intelligence and these kind of computer programs are just based on predicting what the best output should be. So it's just doing that with words. And artificial intelligence has actually been around for decades. So way back in the 1940s, a couple of computer scientists and neurologists came up with this idea of a neural network, where basically having different parts of a computer program do what the neurons do in our brain and deciding whether or not to fire or send some information based on the information they receive. And that in and of itself is kind of a tricky concept to grasp. Definitely took me a little while to feel like I fully understood it. And then it gets more complicated when you layer many, many of those on top of each other. And these things called neural networks, and there's many different flavors of neural networks. But for years, decades really, these were limited by computing power. So there were a few kind of like dark ages or like frozen periods of artificial intelligence where the ideas people were having for programming them couldn't really be kept up with by the computing power that was available. So for the parents in this seminar, some familiar highlights might be the IBM Deep Blue and Watson computers winning at chess and Jeopardy against human world champions. So that's something that a lot of people took as like, oh, computers are getting pretty good at these things that humans tended to be really good at before. And that was really cool, but you wouldn't mistake either of those computers for a human if you're having a conversation with it. They were pretty specifically designed for the tasks they were good at. And something that came along in the early days of artificial intelligence, I believe in the 1950s, a scientist called who was named Alan Turing, came up with this idea of the Turing test, which is that to evaluate artificial intelligence, you could try and have a conversation with the machine. And if it responded the way a human would, and you couldn't really tell the difference, then it was a pretty good model of a human. And we're starting to get to the point where these kinds of programs, including ChatGPT, are actually passing the Turing test. You can't tell the difference just by talking with whether or not they're a machine. So this does kind of bring up the question of what is artificial intelligence? What is machine learning? Like I said, there's so many terms that just get tossed around here kind of interchangeably. And artificial intelligence is kind of the most general version of the field. Machine learning is a more specific version of that that involves training a computer program on data to identify patterns and make predictions. Now, that might sound like all AI or artificial intelligence, but there's um, a lot of other versions where we might not use so much data, or we might not be running quite the same sorts of models to make predictions. So when we get into machine learning, and especially deep learning, using that tool called a neural network that I mentioned before, usually requires lots and lots of data. So sometimes this isn't the best tool to use if simple statistics or other models work better, just because it can take a lot of time to collect and process that data. And we also need to be able to evaluate the predictions, whether it's trying to classify things or predict the value of a stock or the population of a city at some future time. We need to have some testing data that we use to know whether those predictions are right or wrong. Now, all this involves a lot of math, statistics, calculus, algebra. But the part that's interesting to me about that is some of that math, like especially algebra or just plotting the equation of a line or a curve, is something that a lot of high school students can do. So when we get into talking about our machine learning courses later, that's something we truly try and draw out of it, that the math, when you really break it down, isn't as complicated as it may seem at first. So we'll try and keep this presentation pretty jargon-free and accessible, but one term you may hear if you're listening to podcasts or reading up on these current events is large language model. And that's what these advanced chatbots are, like ChatGPT. It belongs to a field called natural language processing, which is basically what the Siri or Alexa app does. Any text-based or voice-based virtual assistant is trying to use language the way that humans do. So in education, there's been a lot of discussion about what this means for students and teachers having something that can act pretty intelligently and answer questions pretty intelligently. The fear is that students might cheat by having ChatGPT do all their homework or answer papers. I was listening to one teacher on a podcast say they're really glad this didn't come along during the pandemic when everything was online, because obviously the less students are supervised, the more they can just log on to a site and try something like this. There's also a fear of some jobs and careers becoming obsolete. And that might include teachers, if something like grading papers or even generating lesson plans can be outsourced. I don't think we're there yet for some reasons I'll touch on, but hopefully, and this gets into the opportunities part, it can be more of a tool for teachers to use than something they fear as their replacement. One reason for that is that as it is, this model doesn't really produce the kinds of papers or writing or the sort of work that students would be doing at high school levels and above. It can maybe do like a 5-paragraph essay that a 5th or 6th grader could write and be a convincing replacement for that. But then for any kind of creative writing or longer papers, it doesn't really get there yet. And so we more see this as an opportunity for students to use the software as a tool. If they're trying to give it a prompt to get some output back, they actually have to think really critically about what they want to frame as the important parts of their paper, or how they're going to proofread the response to make sure it fits the assignment. And yeah, a lot of the times it might fall short. They might just end up having to do it all themselves. Now, that does also make a convincing argument for keeping younger students off the platform, especially, the less worldly experience you have, the more you might relate to this as like another human being or a friend, which could be kind of dangerous. But it does present opportunities, at least for older students, to use software as a tool and learn to do that. Used correctly can also make teachers' lives a lot easier by giving immediate feedback that you wouldn't get otherwise, or helping to generate lesson plans using everything on the internet, kind of like the what Microsoft is trying to do, building this into like a more advanced search engine type of thing. That said, it still does have a lot of limitations. Like when we get into our live demo later on, there will be some responses that are just kind of lower quality, and maybe like the speed that it's generated at or the length of response isn't exactly what we want. So I'll hand things off to Malcolm in a second to talk about these kinds of models and programming, what that can look like. But in general, as CS educators, we don't really see our field being so set apart in this regard from education in general. There's pretty similar risks and opportunities. And one example would be for those of you who have students in our classes, maybe a student in a very beginner class could send their homework problem to ChatGPT and say, write this function or debug this code, and it would give them the right answer right away. But more often, and especially at the higher levels, we see kind of the opposite, that it'll respond really confidently, but have some errors, or give students something that appears right, but actually might be wrong. And in those cases, students still need critical thinking skills. They still need to be able to evaluate something for themselves, tell whether it's right or not. And eventually, we still do see that as valuable, using a software tool like this to generate a response, and then checking it out, seeing if it fits what they're actually looking for. And something I've used as an educator myself is just the potential for lesson planning and providing feedback. So if you have a big topic you want to tackle, like even in our machine learning courses, if we're trying to understand a concept in class, I might ask a chatbot like this for an outline of a lesson and just take some of the bullet points that I think have the most potential and kind of turn that into a lesson from there. So in general, we don't see it replacing computer science educators just yet, though it has been a really helpful tool for a lot of situations. And I think I'll hand things off to you there, Malcolm, if that works for you. If folks have questions on any part of the presentation, feel free to post them in the chat or the Q&A, and we'll do our best to answer those towards the end.
Thanks, Mark. All right, so I'd like to talk about what I think the potential is for software development and programming using AI. First, I want to sort of just give some context to the predictions. Making predictions about the future of AI and computers is a dangerous space to be in. As Mark said, in 1987, computers beat humans playing chess with Gary Kasparov. For a long time, we thought, that sort of complex, chess doesn't quite have the complexity of a board game like Go, which is just massive amounts of permutations that will always have that. But no, they beat us in 2016. They're immensely complex video games like Dota 2 with many players on a team and communication back and forth all live. They beat us at that in 2019. So it's difficult to say for sure. Computers will never be able to do this. That's a statement I make less confidently these days. The flip side of this, on the other hand, is that it can be difficult to say what they will be able to do in a little while. Elon Musk, I think, first promised full self-driving in 2014 as something that was coming next year. And then in 2015, he made that promise. In 2016, he made that promise. And I think it's every year it seems to be just on the horizon, but not quite here. But let's talk about programming specifically. Machine learning and these tools are useful for many professions, but for programming in particular, because perhaps right now, just because the people that are developing this AI software are also software developers. There's a lot of exciting things going on. One of those is just as a general purpose assistant using ChatGPT, for example. If you're a junior developer, you can treat ChatGPT as like a knowledgeable teaching assistant, perhaps. You can ask it, how do I write this code in this language, or how do I add things to a set in Java, or you'll get a confident and usually well reasoned explanation. There are some tools that will provide local knowledge. In addition to being trained on immense amounts of data on the internet, you can train them on your local code base, on the program that you and your team are working on, and ask it questions like, show me the code that handles user login, or where is the database connection handled? These kind of things are in a larger code base. When you're starting out, even at a senior level, often they require talking to someone else on the team who knows, who has more experience, and having that sort of knowledge available immediately can be very valuable. But the last type is just as a programming assistant. These tools can actually write code for you, and so some sort of look to the future and imagine a world where humans don't write code anymore, where the AI has eaten us out of a job. But well, yeah, I'll talk about that a little bit later. For now, I want to go into this AI assistant, because one of the popular ones is called Copilot from GitHub. GitHub is a big company owned by Microsoft, so they have a lot of financial backing, and this is a widely used tool now. Came out late last year. Millions of users, I would guess. I use it daily, and effectively what it does is it feels like a little someone sitting next to you, who sometimes just suggests a little bit on the keyboard for you. Let me show you how that works. Here I've written a function called calculate gross. It takes a net and a fee, and Copilot has jumped in and suggested, oh, maybe I'm about to type return net plus fee. So in that case, I just hit tab, it fills it in for me, and it feels like a nice little valuable assistant. It's when it works very well. It's they've trained it on billions of lines of code, they say. When Mark, they're called large language models for a reason. That's the size of the training sets that they're usually trained upon. It'll auto-complete small snippets of code, like in my example here, but it'll also do big snippets if you want. You can write a loose description of the code that you want to write, and it'll automatically fill in 10, 20, 30 lines of code for you, which may be the code that you wanted. Sometimes the suggestions are obviously wrong. It just may not work immediately, but sometimes, and this is the dangerous case, sometimes the suggestions are subtly wrong. There's a saying in computer science where debugging your code is twice as hard as writing the code in the first place. And this is a warning against writing code as cleverly as you can. But in this case, if you didn't even write the code, if Copilot gave you the code, there's a very likely chance later that you will end up debugging it. I would say a minority of the time that software developers spend during their days spent writing code. We spend a lot more time reading code and debugging code and trying to figure out why something doesn't work the way we expect it to. And Copilot is, it's important that we use Copilot as maybe a tool to aid us in the code that we would normally be writing, but not necessarily a crutch, or we end up in dangerous territory there. So now, looking to the future, this is where I make a risk of making a fool of myself with predictions, but I think we can safely say AI is getting better. The rate of progress impresses. Every month there's something new and amazing coming out, and I think ChatGPT is the latest instance of that. These AI tools are already quite good at the trivial stuff, like the calculate gross method that I showed before. It still does make mistakes, but maybe 90% of the time it's right. 80, 90%. That's quite useful. But with a lot of these things, and I think with self-driving cars, we see another example where 90% is doable with quite a bit of work, but then getting to 95%, requires a lot of work, and then getting to 99%, and getting that last distance where something is properly reliable is very, very difficult. And though a tool that is right 99% of the time seems pretty good, if when you spread that out, being wrong 1% of the time is quite significant. So I personally, I'm not worried that we'll write a few lines and then entire code bases will be generated. I think where human beings are going to have an important place in the software development process for a long time to come. Optimistically, I think software developers might just end up writing a lot less of the boring code. People sometimes refer to some of the code that people often write as plumbing. You've got a user interface here and a database here, and you just need to connect the things up. There's data needs to go back and forth, and somebody needs to connect that up. It's not automatic, but maybe it could be in a world where AI gets a little smarter. I think that the interesting things, the more complex stuff is always going to be there. Humans will always need to be in the mix, if only because at the end of the day, someone needs to talk to the users or the clients to understand what exactly their needs are. And I think fundamentally that is what a software developer does, is someone who talks to the users of software, understands what they need, and then translates that to a form that a computer can understand. I want to show a few demos here because I think that that ChatGPT is something that really is best demonstrated just by looking at how it works. Here's I think a good example of some of the values and the flaws in it. Let me make this a little bit bigger for everyone. So I asked,
and Malcolm, I think we
what's
can still
heavier, a
just
pound
see
of
your
feathers?
presentation screen.
Oh, thanks.
Yeah.
Let me change. I'll just share my whole screen. Is that better?
Yep. Yeah, that's great.
Okay, so here I've asked, what is heavier, a pound of feathers or a pound of bricks? That's a common trick question. Now, ChatGPT has basically been fed all of the text on the internet, loosely speaking, and so it's seen this before. It knows, okay, almost before I've finished typing, it's like, oh, yep, I know this question. You can't trick me. A pound of feathers and a pound of bricks weighs the same amount, which is 1 pound. Okay, we couldn't trick it on that one. But if I ask it, I hope this still remembers. I can ask it, what's heavier, a pound of feathers or 2 pounds of bricks? And the answer to this question is quite obvious, but ChatGPT gets it wrong. But both a pound of feathers and 2 pounds of bricks weigh the same amount, which is 1 pound. And this is a great example of the flaws in the technology, where it doesn't understand what a pound of feathers is or 2 pounds of bricks is. They're not concepts that exist in these language models. Instead, it's essentially pattern matching and saying, oh, yep, here we go. I know this question. I've seen this one before, even though it's slightly different. People word questions differently. And so it's giving me essentially the same answer as before. To its credit, I then asked, are you saying 2 pounds of bricks weighs 1 pound? And no, okay. It corrects itself. That was a typographical error on its part. But luckily, hopefully that wasn't on the test and we didn't hand that in as our answer, because we would have got that one wrong. Let me show some programming examples. Processing is the name of a software library that we use. If you have any students in our classes, they're probably familiar with it. Processing is a way to easily input code and then see something visual. You can easily put text on the screen or a circle or squares and manipulate them. Here I asked for some processing code of a colorful spinning cube. And I'm not going to explain this code here, but if I put that in our coder, this is something that would have taken me a fair amount of time to write out. But here we get a colorful spinning cube. And this is, I guess I want to get across how incredible this was the first time I did it. That, it's not looking up some library of, oh, if someone asks for this question, then give them this response. Like it's not a dictionary. It is, doing complex algorithms. Take Mark's AI class, and I guess you'll be able to understand it better than I do. But that's that's the kind of code that would have taken me 10 minutes to write. And you can then go back and forth with it. I asked for a grid of 16 cubes all rotating on different axes. And here the code didn't quite do what I asked. You can go back and forth and have a conversation, but effectively, the more common an answer is in the corpus of text, the more widely discussed and agreed upon an answer is, the more likely ChatGPT is to give you a correct, accurate result. Another little example of the flaws here is I asked for a simple math calculation, which this is the one thing computers can do, right? Like your pocket calculator from your childhood can add numbers together. But here, I mean, I don't know what this is off the top of my head, but I typed it into a calculator and ChatGPT gets it wrong, and that's because it's not doing, it's not following the typical path of typical software programs of entering numbers and adding them up and subtracting them. It's doing this sort of predictive text, not too dissimilar to the autocomplete on your keyboard. And so here, this is off by 90 or so, which is interestingly close, but still wrong, and wrong in a way that that you don't expect computers to be. Okay, lastly, I just want to demonstrate sort of just how interesting and creative it can be. You can ask it almost any question you want. Why is the sky blue? And I mean, dangerously, I don't know why the sky is blue. So ChatGPT could be lying to me here, but to some extent that applies to a lot of the searching for answers on the internet. But regardless, that looks quite authentic. I learn a fair amount. You can maybe, do other planets have different colored skies? Skies on other planets in our solar system can have different colors due to their unique atmospheric compositions. So we get, that as a learning tool, I think this is really valuable. But it's not just for learning. You can you give me that answer again, but in the style of Dr. Seuss? Oh, yes, I can give it a try to explain the colors that fill the sky. On Mars, it's reddish orange you see. From iron oxide, it gets its hue with glee. There's, yeah, you can ask it, okay, how about in the style of a pirate? Yeah, you can spend a lot of time messing around. Look at this. It's still doing it in a form of a poem. Yeah. Anyway, I think we're getting a little off topic here, but yeah, these tools are very powerful. Like any tool, you can use them wisely and you can use them incorrectly. But I suppose I want to get across. I would definitely recommend that everyone here visits chat.openai.com. It is free. You have to log in, but then try just answering questions back and forth, experiment with it, try to figure out where the boundaries of its knowledge are, what the limitations are, because you can really see a lot of potential, but yeah, it's not perfect. Worth trying out. Thank you, Mark.
Thanks, Malcolm. I'll take the screen back. And we're getting close to our Q&A section, everyone. So if you have questions, I do want to stress, because it's kind of a technical topic, that there's no unintelligent questions here. Definitely, I'm sure anything you're wondering about, many other people, probably including us, are also wondering. So feel free to put those in the chat or the Q&A, and we'll get around to those in just a minute. I'll go back just for a couple of wrap-up slides and some links. This one we're actually not going to spend much time on, but when I was thinking about live demos, I thought this would be kind of funny as prepping for the seminar and asked how you'd explain machine learning to parents of school-age children with no programming background. And it gave some pretty good examples there. One was just looking at a lot of pictures and being able to tell what each one is, which is obviously a bit different from what we're seeing here. Did really get to the feedback part pretty quickly, which I thought was interesting. It's so like teaching a child how to recognize animals, show them pictures of different animals, tell them what each one is, and then gradually they learn to recognize them on their own. So definitely some really interesting potential here. We really encourage you to check it out. And that is one of the links we'll provide here. I realize these aren't clickable for you right now, but I'm happy to copy them into the chat if you'd like. You can send me and Malcolm a direct message. Or if you get these in an email today or tomorrow, you'll be able to click on them there as well. I also did want to spend a little bit just talking about how we support these kind of topics at KTBYTE. I think one of the really powerful opportunities here is for students to learn these things while they're in high school age, maybe not middle school, but starting to understand these concepts so that by the time they get to university, they might even have a direction they'd like to take these ideas in that's new and original. And the section of our site that shows that, let me make sure this link still works, is, I might have to fix this one. The Python and machine learning section of our classes page. There we go. We do have a couple intro courses in Python listed here. Python is generally the language of choice for data scientists. So even though we don't teach it in all of our classes, that's because Java is still more widely used for competition programming and things like the AP computer science exam. Python is really powerful for this kind of data science and machine learning code. So we're trying to provide more of a pathway for students to study up in that language if that's what they choose, starting with block-based code if they'd like to, getting into more of our machine learning and deep learning courses later on. And we've been doing this long enough that we have a pretty interesting body of research from our students that, again, would encourage anyone to check out if you're interested in what high school age students can do with this material. I haven't uploaded the ones from this year yet. So there's a few from the fall 2022 term that are missing. But you can see there's some interesting science-based topics, flower classification, art genre classification, a few health topics, which are really interesting, cancer detection and medical expense prediction. And the list goes on. So you can kind of click on any of these. Our developers, including Malcolm, have done a great job of making these nicely readable on our website. And I think my computer's just loading slow because I have so much going on. But usually these do load pretty quickly, and you can even download them and read them for yourself if you want to. These do make really good science fair presentations, portfolio pieces for students who have a goal of getting into this at some point. So I do like to share about that just because I know a lot of what we support tends to be competitive programming focused or just learning as much material as possible. But for students who do have a research goal or that kind of motivation, this I think could be really motivating for them as well. And finally, we just have our Q&A here. So I'll give a few minutes while I release the exit poll if folks want to share any questions they have on this topic. And the exit poll does include a question of one, what seminars you'd like to see in the future. We always appreciate that one for helping us to plan these events. And also whether you'd like to be contacted by us about our courses in general. That could be whether or not your student is currently taking a course or plans to take a course. If you're just curious about education in general, or especially this pathway for education, the research side of things, we'd be happy to connect with you about that and have some conversations. So thank you to everyone who's filling that out. And yeah, if you have questions, feel free to leave those for us now. And otherwise, thank you for joining. We'll be excited to share everything that came out of the seminar over the next couple of days. I'll probably end up sending the follow-up email late tonight, early tomorrow. But yeah, looking forward to following up with anyone who requests it as well. I put this in the chat too, but you can let us know either here or after the fact if you'd like to see any of the chat transcripts. Though I do still encourage you, as Malcolm did, to just go out and try it yourself. I think that can be a really fun way to interact with it. And we do have a quick question. Are there research or is there research options for AI machine learning related to a robotics? That's a really good question. I think it's enough of an advanced field for us to tackle and for most educators to tackle that we haven't tried tying it in with robotics just yet. Something I was talking to an old mentor about today, actually, unrelated to KTBYTE, was using robots for data collection for machine learning. So I think something like that has a lot of potential, even for a student coming out of our pretty beginner level robotics courses. It doesn't take much to hook up a sensor and start gathering data. And if you pair that with another student or the same student knowing how to handle basic machine learning, you could start to do some really interesting plotting and prediction of temperature trends, even if it's just in your home or your backyard. And that's like the building blocks of models that get used for climate science and things like that. So I think definitely there are research options out there. If any of our students have a robotics background and want to bring that into one of our machine learning courses, we'd happily support them. And I know that some of our robotics teachers and tutors have taken our machine learning classes as well, so they might be open to it. And on the, I know the fully self-driving or auto-driving cars conversation came up at one point in Malcolm's presentation. I don't know off the top of my head about any research opportunities involving machine learning and self-driving cars, but I'm sure they're out there, and I can follow up about that in a separate email. All right. Seeing no other questions in the Q&A, and it looks like pretty much everyone who's still here responded to the exit poll. So thank you for doing that. I'll close that down and stop our recording. I guess I could stop screen sharing too.